Hello everyone, this is Harrison Galway, and today I'll be teaching you how to factor using the sum of cubes and difference of cubes formulas. So these stand in stark contrast to difference of squares because while you can factor a difference of squares, you cannot factor a sum of squares. But cubes, you can factor both a sum or a difference of two things that are cubed. So first, I'll just show you the formulas. Now, I like to do the formulas at the same time because they're very similar. So I'll split up the screen left and right and show you them both at the same time. So both the sum of cubes and difference of cubes formulas kind of look the same. You have a smaller factor and a larger factor. Same thing over here, smaller factor and larger factor. Now, the terms are the same. It goes a, b, a squared, ab, b squared. Again, same thing for the difference of cubes. A squared, ab, b squared. Now, for the signs between the terms, I remember them using this sort of mnemonic device. Do it in green here. It's SOP, which stands for same, opposite, plus. What I mean by that is when you're figuring out what the signs are, for instance, for the sum of cubes, the first sign here will be the same as what you had in your original expression. So same, which is a plus, opposite, which is a minus, and then plus is always the third sign. Same thing over here. With our difference of cubes, we had a minus sign. So the first sign here will be the same, then the second will be the opposite, and then plus always for the third sign. And those are the formulas. And you can see that if you've memorized one, you've really memorized both. They only differ in terms of their signs, and this mnemonic helps those to helps you to memorize those. So we'll now look through a few examples where we factor some differences in sums of cubes. So the first example here, we see we have x cubed minus 8. So one thing I like to do when factoring these is I say really briefly, what cubed is x cubed? What do I need to cube to get that first term? Well, that's going to be x, obviously. And what cubed gives me the second term, 8? Well, that's going to be 2. And so by doing that, you've identified what a and b are. So when we use our pattern, it'll be really easy to just plug those things in for a and b. So you'll recall that our pattern here, we have a smaller factor and a larger factor. And you'll remember it goes a, b, a squared, ab, b squared, right? So that's going to be a, which is x, b, which is 2, a squared, x squared, ab, 2x, b squared, 4. And then for the signs, we have same, opposite, plus. And we're done. As always, we check to see whether there's anything that's still factorable any further, but neither of these two expressions are factorable. So we're done. On to the next. So now we see a sum of cubes, x cubed plus 27. We first, we recognize that obviously this is a cube, and 27, of course, is a cube as well. So let's identify what a and b are. What cubed is x cubed? Well, that's easy, that's x. And what cubed is 27? That is 3. And there's our a and b, so the rest is just to fill in using the pattern. So again, it goes a, b, a squared, ab, b squared. So first we have a, which is x, b, which is 3, a squared, which is x squared, ab, which is 3x, and b squared, which is 3 squared, so 9. And then we just need to put in the signs. We go same as the original sum of cubes, so same would be plus. Same, opposite is minus, and then plus always for the third, and done. Anything else factorable? Nope. Moving on to the next problem. So this one is less obviously a difference of cubes, right? Because we have this x raised to the 6th power. But if we remember our exponent rules, one of them says that if we have some exponential raised to another power, what we do is we multiply these exponents together. So this becomes x to the a times b. And so it turns out that we can cube something to get x to the 6th. So think about it yourself. What would we need to cube to get x to the 6th? What cubed equals x to the 6th? Well, if we take x squared, since we multiply those exponents, that's going to get us x to the 6th. And then what cubed equals 125? That is just 5. So there are our a and b. Now just to fill in the pattern. As you'll remember, it's a squared, b squared. So a is x squared this time, right? Because again, we've identified our a and our b here in these parentheses. So a, x squared, b, 5, a squared. So what is x squared squared? Well, again, thinking about this exponent rule, x squared squared would just be x to the 4th, right? So that's x to the 4th here. AB, so that's 5x squared, and then b squared is 25. For our signs, same, opposite, plus as the original. Done. 2 more. This one's interesting, right? Because we have now this term with 2 variables in it. So again, just like we have been, let's identify what a and b are. All right, so what do we need to cube to get this first term? Well, to get the a cubed, we'll just have to cube a. And to get the b to the 9th, we'll have to cube b to the 3rd. Right? And, if you want to double check, you can just sort of distribute this exponent into each of these. And indeed, it gets us what we need. So that's a. What about b? What do we need to cube to get 1? 1. So our factors. We have that smaller factor and then that larger factor. The pattern, once again, goes a, b, a squared, a, b, b squared. So we'll just throw them in. A, which is ab cubed, b, which is 1, a squared, so that's a little bit trickier. Let's do that over here on the side. What is a squared? So a was ab to the 3rd. And what do you get when you square that? Well, that would give us a squared b to the 6th using that exponent rule. So that's what we put here. A squared b to the 6th. Then we have ab. So we just multiply a times b. So that's just ab cubed. And then we have b squared. 1 squared is just 1. For our signs, we do same, opposite, plus. And done. 1 more. So now, on this one, we have coefficients on both terms here. So let's go through the same steps. What cubed gives us this first term? Well, the 4 cubed gives us 64. And x cubed gives us x cubed. And then for this 27y to the 12th, what do we need to cube to get 27? That's 3. And what do we need to cube to get y to the 12th? That must be y to the 4th, right? Because we multiply those exponents. So we found a and b. Now just to plug them in, we have a, 4x. B, 3y to the 4th, a squared, so that's going to be 16x squared, ab, right, so let's multiply these carefully, a times b, 4 times 3 is 12, x, y to the 4th, and then b squared, so that's going to be 9y to the 8th. And then we'll put in our signs, same, opposite, plus. Done. So there you have it. That is how you factor using the sum of cubes and difference of cubes. patterns or formulas. And I hope this video was helpful. And please check out my other videos. Thank you very much for watching. Take care.